Hello, in this example 5, I will do integration by trigonometric substitution, but there will be a completing the square method. So if you look at our problem, we got to take the integral of dx or 101 dx over square root of x squared minus 6x plus 10. So why this problem, what makes this a little bit more different from the other ones is we got to complete the square, right? Because what we have is x squared minus 6x plus 10, right? We kind of have to make it look like one of our identities, so that's why we have to complete the square. Uh, you're basically when I say completing the square, you basically got to put it in vertex form. That's what they really want you to do. Put this into vertex form. Um, remember, this is a quadratic in this in standard form. You can convert a standard form quadratic into a vertex form by completing the square. So let's do that. So we have x squared minus 6x plus 10. So we're going to complete the square or put it in vertex form. So the first step is move the constant to the right. So our constant is 10, right? So we're going to move it to the right. So we have x squared minus 6x and then blank space. And then on the right, it's 0 minus 10, which is negative 10. Now, what do we put in this blank space? You basically take half of your b and square it. So if our b is negative 6, take half of that, which is negative 3. And then you're going to square that, which is 9. So you're going to add 9 here. And you also have to do it on the other side, right? So you get x squared minus 6x plus 9. And then what's negative 10 plus 9? Negative 1. Okay. Then what you do is kind of like go backwards. You got to put this in factor form. This x squared minus 6x plus 9. So how do I put that in factor form? It's just parentheses x and then half of your b, which is negative 3 squared equals negative 9. Then what you do is you want to put in vertex form. So all you got to do is move this negative 1 to the other side by adding 1 to both sides. So you have x minus 3 squared plus 1. So this whole thing right here can be simplified as this. So x squared minus 6x plus 10 can be factored out as parentheses x minus 3 squared plus 1. Okay. So now we got to use one of our identities. We have x minus 3 squared plus 1. So that is related to our uh, so this right here, square root of x minus 3 squared plus 1, looks very similar to the rule of uh, x squared plus a squared, right? So if you use that rule, that means you're going to use this rule, x equals a times tan theta. Okay, so let's compare this with this. What do you think our x value is and what do you think our a value is? So believe it or not, our x value is not just x, it's actually this whole thing, x minus 3. Yeah, so our x is actually this whole thing. And then our a value is what number squared gives you 1? Well, that's just 1. So our a value is 1. Okay, so what would I do next is uh, I could substitute x minus 3 in the bottom. I could substitute x minus 3 with 1 times tan theta or tan theta. What I should do first is because we have a dx here, I'm going to find that dx. So how do I find it? It's simply taking the derivative on the left side and the right. So what's the derivative of x? In terms of dx, it's 1 dx. the derivative of a constant is 0, so I don't have to worry about that. Minus 3. And then what is the derivative of 1 tan theta, or really tan theta? It's just secant theta. Wait, I went way a little bit ahead of myself. So on the left, so what we're doing is we're putting everything in terms of theta. So on the left side, what is the derivative of x minus 3? It's just 1 dx. And then on the right side, what is the dx over d theta? So we're basically taking the derivative in terms of theta. And then on the right side, what's the derivative of tan theta? It would be secant square theta, right? So I just want to solve a regular dx, so I have to get rid of this d theta. So I'm going to multiply both sides by d theta. So on the left, d theta cancels. You're just left with dx equals to secant square theta. Okay, so now we can replace dx with secant square theta d theta, and then we can replace x minus 3 with tan theta. So dx is secant square theta d theta. And then you can replace x minus 3 with tan theta. And then it says we have to square it, so square this whole thing, plus 1. Okay, now we're going to simplify. So this would be secant square theta d theta over tan theta square, that's tan square theta plus 1. Okay, so is there any identities you can use? Yes, we can substitute tan square theta plus 1 with what? So it's related to your trig identity. So your trig identity would be 1 plus tan square theta equals to secant square theta, right? So this is going to be secant square theta. This is not, it should be theta. And then you can replace tan square theta plus 1 with secant square theta, right? Oh, wait. Sorry, yeah, so silly. I forgot there's a square root in the bottom. So that's why. Yeah, there's a square root in the bottom. Okay, now let's simplify. So we have on the top we have secant square theta d theta, and then on the bottom, what is the square root of secant square theta? It's just secant. It just becomes regular secant theta. Okay, and then you just cancel as much as you can and clean it up. So what cancels? This secant theta cancels, so you're just left with so this cancels, this becomes a 1. So you're just left with secant theta d theta. Okay, so what is the integration of secant theta? It is it's just ln of absolute value of tan theta plus secant theta plus c. So this is something you should know. The integration of secant theta is ln of absolute value of tan theta plus secant theta plus c. So remember, our final answer has to be in terms of x. So we're gonna have to draw our right triangle. So we could put theta here, and then what were we were given that x minus 3 equals to tan theta, right? That's what we use as a substitution. So if you do the SOHCAHTOA thing, tan is opposite over adjacent, so this has a bottom of 1. So this x minus 3 is the opposite, and then this 1 is the adjacent. So this is 1, and then this is the opposite side, so it's x minus 3. Do we need to find the hypotenuse? I believe so. Yes, we got to find the hypotenuse before we go any further. So because it's a right triangle, we could do Pythagorean theorem. So it's going to be 1 square plus x minus 3 square equals c square. Okay, so 1 square is 1 plus, what's x minus 3 squared? That's x squared minus 6x plus 9 equals a c squared. And then just clean this up. It's x squared minus 6x, and then 1 plus 9 is 10 equals to c squared. And then solve for c, so you're going to take the square root of both sides. So you get c equals the square root of x squared minus 6x plus 10. Okay, so this hypotenuse is square root of x squared minus 6x plus 10. Okay, so now we could just, so let's just first figure out tan theta and secant theta. So what is our tan theta? Oh, that was given. Our tan theta was x minus 3. And then what would be our secant theta? So secant is related to the cosine, which is basically the opposite of cosine. So if cosine was adjacent over hypotenuse, secant would be hypotenuse over adjacent, right? So our hypotenuse is square root of x squared minus 6x plus 10. And then our adjacent is just 1. Okay, so our final answer is ln of absolute value, and we said that tan theta is x minus 3 plus secant theta is square root of x squared minus 6x plus 10. And then over 1, you don't really have to put that 1, and then absolute value, and then plus c. And that is your final answer. So what makes this problem special is we had to do completing the square in order for it to look like one of our identities. Okay, I will stop here. Okay, thank you.